So we will be taking the concept of what? Heap sort, right? How to perform heap sort. Any idea, by the way, how we may try performing the heap sort part? Tell me all. How we may try performing the heap sort part. Any idea, by the way? What is heap sort? See, heap sort is nothing but a sorting that we usually do with the help of heaps. Suppose that you are having an array. What we are to sort, by the way, an array of values, right? 4, 5, 1, 2, 3, 6. Okay. Suppose that I ask you, make a min heap of this. This is the given array of values, right? I can convert that. Any array can be converted to a min heap. Am I correct onto that? If I try visualizing this array of values for me, suppose, then how the heap would be looking like? 4, then 5 and 1 are the child nodes of 4. Then afterwards, 2 and 3 are the child nodes of 5, and 1 has a child node 6, right? This is how I have formed a heap out of this. So if you convert that to a min heap, how that's going to be looking like? Any idea? If you convert that to a min heap, how that's going to be looking like? First, 1, 6 is already a min heap for me, right? 5, 2, and 3. This needs to be converted to a min heap first, right? So the first step I'm going to be taking is convert 5 to 3 into a sub min heap, right? So that the entire structure can be converted to a min heap going forward. So it would be nothing but 2 and 5 would be taking its position. 3 is here, afterwards 1 is here, and 6 is here, right? Then convert the entire structure to a min heap going further. Both the sub heaps that are starting from 2 and 1, both are min heaps for us. Then I need to convert the entire structure to a min heap. How to convert that, by the way? Tell me someone. Tell me someone.
So one
Yeah, 1 and 4 would be swapped with each other, right? 1 and 4 would be swapped with each other. So 1 would be going in place of 4, 2 remains as it is. So if 2 is not replaced from its position, right, entire sub heap from 2, whatever I am having, that remains untouched. I am just bothered about wherever 4 is going, is the sub heap corresponding to this. Has this been at all distorted? No, not at all, right? So no, the sub heap nature, that 4 still, if I replace 4 in position of 1, 6 is again greater than that. So entire nature, whatever used to be, right, that remains as it is. It's just that 4 and 1 has swapped their position. So can I just say right now, the entire structure has got converted to a min heap for us, right? So if you right now see the value of the arrays, how that's going to be visualized? If you see the values of arrays, how that would be visualized? Now I can say array has got the values as 1, 2, 4, 5, 3, 6. Is it that? All of you agree with me on this? Since I've converted that to a min heap, would you agree that the smallest element has gone to the 0th index? Would you agree with me on this? The smallest element has already got sorted. Am I correct? Into the 0th position, because I've converted the entire array values to a min heap, the smallest value has arrived. Now, next, what I'm required to do? Can I just say, okay, whatever are the remaining parts for us, convert that to a min heap, convert this to a min heap, and then do what? Try bringing the smallest value of this region to the first index. Can I try something like this? Would you agree with me on this? Already into the 0th position, right? The smallest value is there. Now my task is into the convert the remaining elements from index 1 till index 5, whatever we are having, into a min heap. And then you do what? Then what is required to be done? Tell. Then what I'm required to do? Whatever is the smallest value after converting the entire structure to
partition ta badhate hobe 2 er pore.
Converting the entire structure to a min heap, what will happen? Tell me that.
So
The
1, 2 sorted.
The smallest sorted will be coming to the first position, and that's it. So what's the current structure of the min heap that we are having right now? 2, then what is it? 4, 5, and then afterwards, only these values from 1 and 5, whatever I'm having. 2, 4, and 5. Then what's going to happen next?
3, 6.
I think 3, 6 will be here, right? So is this a min heap so far for us?
No.
Is this a min heap for us so far? So what needs to be done, by the way, from here onwards?
So just niche sub treat.
Okay, one thing. Would you agree with me on this that if I start up straight away from 1, then 2 and 3 are the child nodes of the node that is residing at index 1. Is it matching up? 1 into 2 plus 1 and 1 into 2 plus 2. Index 2 and index 3 would be the child nodes of index 1 node, right? And then going further, index 4 and 5 right now would be the child nodes of the second index node for us. Is it going well enough? Is it going well enough for me right now? Tell me that. Is it going well enough? Index 2, its child node is residing at where? 2 into 1 plus 1. And then its child node is residing at 2 into 2 plus 1. So we are getting some wrong conventions here. Am I correct? Index 3 right now is already getting counted as a child node of index 1 node. Right? But as per our convention, how heap operates is that index 2 for index 1, right? Index 2 and 3 would have been its child node. That's coming fine. But for index 2, again, index 3 is coming counted as a child node of index 2. So there is a clash in between index 1 and index 2. So that's the wrong convention what we are operating on. So how can we try fixing this? Any idea by that? Right now, the convention is not working for us, right? Am I correct? Am I wrong? All of you agree with me on this?
So convention to বুঝি নি।
Index 1. This is the root node overall, right? Am I correct? Index 1. Its child node is index 2 and index 3 nodes. Am I correct? Is it correct or not? If I is the root node, then where its left and right child resides?
2 into I plus 1.
Into I plus 1. So if my root starts off from index 1 right now, are we getting index 2 and index 3 as its left and right child respectively? Okay, what about the next node?
So 0 থেকে start করে না আমরা indexing?
Yes, definitely. But 0 is already into its sorted position. Now what you will do?
আচ্ছা ঠিক আছে।
I am not required to convert the min heap from index 0, but from index 1 onwards, right? But from index 1 onwards. Then what I am required to do? Then if from index 1, the overall root of the heap would be starting. Then index 2 and index 3 remains.
Yeah.
They are the left and right child of index 2. Because I'm converting the remaining elements to heap, not the index 1. It's already into their sorted position.
Yeah.
So my point is for index 1, index 2 and 3 would be its root child nodes, right? Then what about index 2? For index 2, what node should be its left and right child respectively? Is it coming again as index 3 and index 4? So is there a clash? Index 3 is both right child of index 1 and index 3 again is the left child of index 2. Is there a clash that we are getting?
Yeah.
So this method is not working in this case. Straight away converting to min heap is not helping. What else I can do? Getting the error, what I am getting, what we are getting if we are playing up with min heap, let me know. Getting the error that the convention, as per the convention of heaps, we are failing somehow. Now next what we are required to do, tell me that. How I can try fixing it? Tell me. Okay, I am telling you that this was our array, right? 4, 5, 1, 2, 6, 5. Let this be my array. Why not to convert this? So if I convert this to a heap kind of structure, 4, 5, 1, then 2, 6 comes here and 5 comes here, right? Okay, now if I ask you, why don't you convert that to a maxi? Works? Why don't you convert that to a maxi? Will it work? Then what would happen is first this sub heap would be converted to a maxi. 4, then 5 comes here, then 1 comes here, right? Then this entire segment, whatever I'm dealing with, the segment from the left child of 4, that would be converted to a maxi. 6 would be coming here, 5 goes here, 2 goes here. And then at the end, what will happen? At the end, what will happen? Swap 6 with 4. Swap 6 with 4. Correct? 6 is the greatest among these 3 nodes. 6 would be replacing 4 from its position. 6 goes here, 5 goes here, 4 comes here, 2 and 5. Again, 4 and 5 would be swapped with each other. So the entire structure at the end would be looking like 6, 5, then 5 here, 4 and 2. Is it converted to a max heap? First tell me that. Is it converted to a max heap for us? The greatest value has gone to the index 1. How this should be looking like? 6, 5, 5,
2, 4.
2, 4, right? Now, how should I proceed ahead? What are your thoughts? The greatest element for surety is present into the index 0. Can I just swap it with index n minus 1? Will it work? Will it work? I think have we missed something, right? 6, 5 here. 1 was also there. Yes, yes. Can I just say, let me swap 6 with 1. If I am sorting in ascending order, the greatest value should be placed at the position n minus 1. Swap 6 with value n minus 1. Whatever is present at index n minus 1. Then what will happen? 1 comes here, 5, 5, 2, 4, 6. The greatest value has moved on to its greatest index, the sorted position. Convert the remaining n minus 1 element into what? Convert the remaining n minus 1 element into what? Tell me that. Convert the remaining n minus 1 elements right now into what? Can I just say convert them to heap again, into max heap, whatever I am having? Can I do it or can't I do it? Tell. Now 1 comes here. I think both the 5s are retaining their positions, and one of the 5 is having its child node 2 and 4. Am I correct? Is it happening? Now my
Yes.
task again is 2. Now what is happening? See, this subheap is also getting maintained. This subheap is also getting maintained. Both the subheaps are as it is. They were max in nature. They are still max in nature. In the previous iteration, these two subheaps were still max. And what happened is that this 1 and 6, they swapped their positions. And afterwards, I can just try assuming 6 got entirely removed from the heap because 6 has gone to its sorted position respectively. Whatever remaining n minus 1 elements, I can try converting that to a max heap again. So what is the observation that's coming into the picture? Both the subheaps, right, that are starting from nodes 5, they have retained their max nature. Now my task only is to check, right? My task is only to check here is whether one compared with both the 5s, with what value should I replace 1 and then go ahead for further heapification process. Am I correct here? Am I correct here? If both the heaps are already subheaps, whatever I'm dealing with, if they are already max in nature, my task is to right now just see root, its lefter node and righter node, which one is maximum. Whatever is maximum, I can just swap it with 1. So either of them, either of the 5 is the maximum value, you can swap it with 1. And then what should I try? Tell me that. Let's suppose with this 5, 1 is getting swapped. Then how the heap would be looking like? 5 goes to the index 0. 1 comes here, another 5 is here. 2 is here and 4 is here, right? Again, 4 and 1 would be swapped with each other. Then finally, my heap is looking something like this. 5, 4, 5. And afterwards 2 is there and 1 is here, right? Still see, even after the further heapification, this is also a max heap, this is also a max heap. It's just that right now, what has happened? The maximum value among the entire remaining structure has got on to the index 0 for us. Then what should I do ahead? If I just say my array is looking like 5, 4, 5, 2, 1, 6 has already been sorted. Now you know that in these values, the maximum value has been placed at the 0th index. What you are going to do right now? What you are going to do? I'm just sorting these remaining segment of elements. What you are going to do? Tell.
Swap it with 1.
Swap 5 with 1. The second largest value should be going to the second largest position of the index. Then I can just, if I swap it, 1 comes here, 4, 5, 2, 5, 6. These two elements have respectively gone to their sorted position. Am I correct?
Yes.
Am I correct? Okay, then I need to sort these remaining segments with the help of a max heap, right? Again and again. Keep on forming the entire array to a max heap till the time we sort the entire array. So what are the remaining segments for us? I think the array is 1, 4,
5, 2.
5, 2, 5, 6. This has been completely sorted. Now my conversion is limited to these elements, right? My conversion is limited to these elements. So how the heap, if I convert this to an entire heap, the indexing starts up from 0. I don't think there's going to be any kind of convention errors right now. Okay. So 1 is there and afterwards 4 and 5. It's a left and right child's 2 is here. I think this segment is also a max heap. This segment is also a max heap. Then what's going to happen next? Tell me that. We
Replace
just
5
need
with
to
1.
see. We just need to see, do one thing. What's it? What is it? We just need to see 4, 5 and 1. Which one is greatest? 5 is greatest. Swap with 1, right? Swap with 1. So my heap would be looking like 1, 4 comes here. Sorry, 5 comes here, 4 comes here, 1 comes here, 2 comes here, right? This is the single inside this sub heap, just a single node already. So maximum. This is also a max heap. No need to touch it because it didn't got touched anyhow in any of the operation. 5, whatever the maximum value among this segment, right? That has moved on to the topmost node, that is at index 0. Am I correct? 5 comes
Yes.
here, 5, 4, 1, 2, and 5, 6. This segment needs to be sorted. This has been sorted. Swap 5 with 2, right? Swap 5 with 2. Then how my overall structure is looking like in terms of a max heap? How my overall structure is looking like in terms of a max heap? 2 comes here, 2, 4, 1, 5, 5, and 6. These three elements have been sorted already. These three elements are yet to be sorted. If I consider this as a heap, how that's looking like for me? 2, 4, and 1, is it? Is it?
Yes.
Okay, so this is also a max heap. This is also a max heap. Now 2, entire structure needs to be converted to a max heap. How you are going to do it? 4 is the maximum, swap it with 2. 4 is the maximum, swap it with 2. Then what will happen? 4 is the maximum, swap it with 2. Tell me, what will happen?
4 to 1.
4 would be coming here, 2 is here, and 1 is here. Already 2 and 1 are max heaps, right? Respectively. Nothing is going to happen next. So after that, what will be happening? Let me know. How the array is looking like here. 4 has arrived here, 2, 1, 5, 5, and 6. Already sorted. Swap 4 with 1. Whatever is the maximum value, swap it with the last position of the unsorted segment. So my array is looking like 1, 2, 4, 5, 5, and 6. Correct? 5, 5, and 6. So literally my entire array has got sorted right now. So if you consider right now, right, if you considered with surety, I can say that these 4 elements, since 4 swaps exactly have performed, these 4 elements have gone to their respective sorted segments. These 2 are yet to be sorted for us. Just one sort operation we are required to perform, and we are good to go ahead with. So if I consider this as a heap, right, 1 is there and 2 is there, if I'm not wrong, right? 1 is there, 2 is there. Since the entire algorithm works for every segment equally, right? So this also would be converted to a max heap. 2 would be converted, 2 would be just swapped with 1. 2 comes here, then 1 comes here. Then afterwards, what will be happening is the array would be looking like 2, 1, 4, 5, 5, and 6 sorted already. 2 is the maximum element. Swap it with the last index of the unsorted segment. The entire array would be right now sorted as 1, 2, 4, 5, 5, 6. At the end, I would be just saying that single element is left to be sorted, right? If into the unsorted zone, there is just a single element to be sorted, then that's already sorted. So I don't require to do anything else. Overall, this is the sorting of the array that we are required to perform. Repeatedly convert the entire array to max heaps. At the 0th index, I would be getting the maximum value. Just swap this element to the last index of the unsorted segment. Is it clear how this is happening?
Yes.
Is it clear how this is happening?
Yes.
All of you. Any doubts? Any doubts? Any doubts? See, there is a conventional error that we are getting, right? Some out of if we are utilizing mini heaps, then some sort of convention needs to be sorted. What kind of convention I can take place so that the child nature of its parent node, as per the index relation, that gets fixed. We know that if the overall root starts off from index 0, the left and right child, they follow the convention very well. But if that keeps on shifting towards the right, then there may be a conventional errors, whatever we are performing. So either the formula needs to be fixed or you change the nature of heap. Either of them works. So we have tried our sorting with the help of max heaps. Fine. Is it clear for
Yes.
everyone? Who will code, me or you people? Will code this. Who will code this? Let me know. Will you be able to do? Just give me 2 minutes. Some call is coming. Yes, tell me, who will be coding it? Me or you? Will you be able to do it or not? Heap sort. Hello. Any answers that I may get?
স্যার আপনি করে দিন।
Okay, let's do it. So let me know that inside this heapify, what should I be changing? Let that be max, right? Let that be max here, whatever index I'm dealing with. And what will happen is that if the current index is greater than array of max, right? And this is also greater than array of max. Am I correct? And we need to convert here min to max respectively. And if max not equal to that of index, swap array of index with array of max. And just go ahead for the heapification process, right? From the max index onwards. Is it what we are required to do? Tell me that. Is it what we are required to do inside the heapification process? So see, for one thing, for the first time, right? For the first time, I need to convert the entire random array to a max heap first. For the first time, you have to run this operation. Entire array has to be converted to a max heap first. Array can be randomly anything. Then needs to be converted to a max heap. Fine. All fine till here. Now see, for the first time, max heap is ready. After this operation, right? For the first time, max heap is ready. Then what I am required to do? Then what I am
Swap with the first element.
We would just say swap. Swap what? Array of 0 with
n-1.
Array of 0 with array of n-1. Now let me know from here onwards what should happen next.
ওই যে আরেকটা লুপ চালিয়ে heapify কল করতে হবে।
Okay, now what will happen? Tell me that. What are the observations that you have got while we were dry running it? What are the observations you have got while I was dry running the program? I think some.
স্যার ম্যাক্স হিপ গুলো দেখছিলাম, মানে প্রত্যেকটা সাবট্রির মধ্যে।
So if you convert this, then how the overall structure is looking like after this? Tell me that.
স্যার একদম প্রথমে বড় এলিমেন্টটা চলে আসবে লাস্টে, লাস্টে
So
ছোটটা আসবে, তারপর ওটা সোয়াপ করে দিতে
I
হবে।
think 7 will be there. Yeah, any kind of it may follow. Let me just try drawing it once. 4, 3, 2 it is initially, then 1, then 6, then 7. Am I correct here? Then I think 6 would be swapping 3, 7 would be swapping 2. Then your structure is looking like 4, 6, 7. And afterwards 3 is here, 1 is here. Afterwards, what will happen next? 2 is here, right? 7 would be swapping 4 further. So overall structure would be looking like 7, 6, 4. And what? 1 and 3 and 2. Am I correct? Now swap 7 and 2 would be swapped with each other, if I'm not wrong, after this operation. So structure is looking something like 2. Then yeah, 6 is here, 7, 4 is here. And afterwards 1 is here, 3 is here. And I think here 7 is there, but that has already moved on to its sorted position. You can just assume this is out of the heap going forward. So what we are able to see, these two sub heaps will retain their nature. Am I correct? No more entire loop kind of structure we are required to run. This is just for the sake of converting the entire random array to a max heap first. But after the swap is done, the sub heaps till the second level, till the just second level of the entire heap, whatever we are maintaining, their entire nature of max heaps, they are getting maintained. Now from the second iteration onwards, I just require to check at index 0, at index 1 and index 2, what are the maximum values. If something is really not well that enough, then I'm going to be straight away doing one thing. Whatever is the maximum, grab it, place it at the index 0 and keep on whatever structure got hampered. Let that be the lefter sub heap, let that be the righter sub heap. Whatever got hampered, just mend that. No requirement to perform the entire heapify operation. All fine till here? All fine till here? So how should I proceed ahead? How should I proceed ahead? Tell me that. How should I proceed?
তাই p5 কল করব
For int I that starts up from where?
0 থেকে লাস্টের আগেরটা
I think for the first iteration we are performing it right. I less than n, I plus plus. Is it the way? For the first time, what to do? We have already done it. Or we can just straight away go ahead with 0 only. I think remaining n minus 1 more times I need to run the heapify operation. Is it that? With a lesser value of n. How many elements are remaining to be sorted? That would be one less than the previous iteration, what has already taken place. Am I correct? So after this swapping has been done, right, just call heapify. Just call heapify on the given heap, whatever we are having. And then what will happen afterwards? Call heapify. Then what will happen next? Tell me.
স্যার একটা কম এলিমেন্ট
From where we are performing the heapification process. From index 0 onwards. Index 0 is the index 0 is right now the place where actually some changes in the previous iteration has happened, right? And based on the index 0's current value, either its lefter subheap would be distorted or its righter subheap would be distorted. Something would be happening, right? So I need to check that whether index 0 is still containing the max value or its lefter child or its righter child is containing the max value. If lefter or righter child is containing the max value, then their respective subheaps may get distorted. So I should keep on heapifying the process again and again. Okay, but either of them would be there. It's not that entire from the lower to the upper level, the entire heapification should be there. But it's that from the upper level, whatever I find the problem, accordingly, the lefter or the righter subheap now should be fixed. All fine. Because apart from the root value, all other values have maintained themselves. Okay, all other nature of subheaps are completely maintained. I don't require to bother about them anymore. Okay, so start off from index 0 and then what else? What else? I just require to pass on that remaining elements for me are n minus 1. Is it that? Is it that? So I think already, right? Overall heapification process I need to run. If there are n elements, you run overall heap sort or heapification process n minus 1 times. No more than that, I feel, right? Because if I run n minus 1 times, I would be left on to sort just a single element. If you are left on to sort just a single element, that's already sorted. Okay, so I just require to say is that, yeah, that's fine. Perform the overall heapification process and heap sort no more than n minus 2 times. Okay, and yeah, so it's not that, okay, fine. This part is done. And so I have to just do one thing. Let me decrease the value of n by 1, n minus minus. And then what I'm required to do, tell me that. Whatever value I'm left up with, suppose the current value of n. After the swap operation, I decrease the value of n straightforward. Whatever is the current value, I can pass it on as it is. Then what I'm required to do? Then what I'm required to do? After the heapify is done, swap array of 0 with swap with the n minus 1 index, whatever I'm having currently. And then afterwards, decrease the value of n by 1. That's it. At the end, whatever may be the overall value of array, that's what is the final sorted version for int I that starts up from 0 I less than. Okay, fine. So we are not maintaining the size, right? That needs to be maintained. Okay, as of now, I know the hard-coded value is 6 I plus plus. Just you can say that array of I. Just print it. Let's see what the overall result comes out to be. Let's see. The error that we have made, why it's taking so long. We try out with any other IDE. So good IDE again, but let's try. I think internet is a bit slower my end. is coming. Array was not declared in the scope. Okay, I'm sorry for this, right? It would be heap, am I, if I'm not wrong. And we have this mentioned here swap. At the end, heap of I needs to be printed. Not declared. Where is it, by the way? 28th line. Sorry for this. Yeah, this would be heap of 0 because we are maintaining everything inside the heap array, right? Try running this. Is it coming well? I don't think so. Till 467 it has been well, but why didn't we do it? Why didn't it happen? So, okay, I'm sorry. I'm sorry. This as per the current value of n, this is running, right? So it may be that I just require to run it 5 times more as per the original size of the array. Since we are decreasing n, we can just deal with the value size here. Let this be equal to 6, right? Let this be equal to that of 6. For the first time, n would be doing the job. And afterwards, what we may try doing is, we may keep on decreasing the value of n. And I can just say, just run it size minus twice. Because based on the value of n, it may be something different that's happening at all. 1, 2, 3, 4, 6, 7. Is it correctly sorted? Tell me that. Correctly sorted for all of us? Is it correctly sorted?
Yes.
Okay, so repeatedly you may try changing the array to some, suppose that 7, 6, 5, 4, 3, 2, 1. Let the value of size be 7. Let the value of n be also 7. Let's see whether we are able to do it or not. 1, 2, 3, 4, 5, 6. But why? Okay, I'm sorry. Why is it so? Can anyone give me the error? Because we have mentioned here value of 6. Let that be size, right? Is it coming well enough? Did we sort it? Did we sort it? Any
Yes.
doubts you people are having, ask me. Corresponding to heap sort, if you have any doubt, then ask me. Any doubts you people are having, let me know. How to perform heap sort. বলো, কোনো ডাউট আছে তো বলো।
Fine.
Able to understand everything? And why we are performing heapify again, not going through the entire loop, is it also clear? Previously, in order to convert an entire heap to any random array to a heap, right? Let that be max heap and min heap. We had to perform a loop. Loop wise, we have to go and perform the heapify from the from the second last level to the topmost level. The entire conversion needs to be done. But due to the single swap operation, right? From the second level to the last level, the max heap or min heap nature of the entire array does not change. It's that the only distortion is that the topmost level. Is that part clear to all of you? Is that part clear to all of you?
Yes.
Tell me, if you are not clear, then I will repeat. Tell me, what is your take on this? Tell me, what is your take on this? And also, tell me that what's the time complexity of heap sort? What is the time complexity of heap sort? Let me bring in the code here for betterment. Why this is not going well enough? What is the time complexity of heap sort? Anyone? Anyone? Any ideas? Any idea? Okay, in order to convert the entire array for the first time to be a max heap, what's the time complexity? For the first time you are converting the array to a max heap. Am I performing exactly n log n operations?
Yes.
First conversion. Okay. Now I can say that I am running this loop n minus 2 times. All of you agree with me? So roughly let that be n times again I'm running the loop. And inside that, I am performing the heapification process again and again. So what's gonna be the time complexity here? Let me know. If you are running the loop overall n times, and for each and every of the n time I perform heapify. What kind of heapify it's gonna be? Look at the root, start from the root at index 0 onwards. Either of its lefter subheap or the righter subheap may contain the greatest element, correct? If it is containing the greatest element, then swap the root value and the lefter subheap's root value. Once the swapping is done, convert the entire lefter or righter subheap, whatever got distorted, into again a max heap. Works.
N log n.
So this is also a log n operation. This heapify call is also performing no more than log n times. So first heap conversion is of log n in log n time complexity. For the second time, whenever I'm trying to sort utilizing a max heap, this is also a roughly n log n operation. What is the overall complexity then? Big O of n log n. Okay, this is the time complexity to solve for heap sort. And then let me know any kind of space complexity we are utilizing. Any space complexity? Huh?
No.
Any space complexity, by the way? We are making recursive calls.
With that space only.
We are performing recursive calls. Will there be any recursion? Will there be any sort of... Can I just say this is the tail recursion by the... Is this a tail recursion? Will you agree with me on this? Will you agree with me on this? The recursive call, whatever I have made, right, is at the end of the entire function call. Still, this is inside an if condition, right? There are two conditions, right? If you make, right, if there is some work that is left to be done, if there is some work that is left to be done after the heapify call, right, there is something to be returned, suppose, then this is not going to be counted on as a tail recursion. But there is no work right now for us. The final result would be considered whatever this heapify call is going to do. So we can assume that this is what a tail recursion call for me. So if this is the tail recursion, then what's the time complexity? What's the space complexity by that? If you have started off with a function called, whatever is the result of the function, that completely depends on its recursive function call, sub problem. Then, right, this is knocked out of the memory and your recursive function call is given the priority. Whatever this will produce, that's going to be the final result. This is residing into the memory. Further, its result depending upon its further recursive function calls. Whatever this will be producing, that would be the result of this. This would be knocked out, this would be kept. So if you are performing tail recursion, right, there is no extra space, some constant k extra space, some constant k extra space would be utilized overall. So your space complexity is big O of 1 in this case. Fine. No extra thing apart from the input array I am utilizing. So overall complexity is also what? Constant in nature, in space terms. It's just that the time complexity is big O of n log. All fine? Any doubts? All fine? Any doubts? Let me know.
Fine.
The heap part is clear. What are min heaps? What are max heaps? How to convert to min heap and max heap, and how to perform heap sort. These are some theoretical topics that you need to consider. Any further doubts you people are having, let me know. Further any doubts? Now you people can try this.
Yes.
Okay, so let this be till today here, right? Next class, I'll start off with the STL priority queue and we will solve some problems on priority queue. Fine? Works for all of you?
Okay.
Priority queue is the last thing that we have to see STL wise, how you don't need to actually implement any kind of heap. We can just deal with priority queues. And once priority queues are done, we'll move on to The last topic, what is it? Graphs. Okay,
Yes.
let's stop it here till then.